Algebra 2, this is Unit 1, Lesson 4, and we are learning about some function notation stuff. Yeah, there's a lot here. There's a lot here. All right, and I think I'm happy that they got a little bit of room to add on to this now. So we learned how to work with this function notation. And if they give us a letter k, that's k of x, and they're defining it in terms of j of x, that means that we are going to take the value of j at when we have the input of x and add 3 to it. So that means that if we, all right, well, let's do this. Find the value of k of 2. Well, right here, that 2 is in the place value where the x would be. So I'm going to try and do a better job of, maybe not a better job, but a different job of explaining things. I'm going to zoom in so we can see things. Okay, the x value is equal to 2. X value is equal to 2. So in order to find the value of k of x at 2, we want to go to the j function at 2, and we want to add 3 to it. So we come over here, we go to the j function when its input is 2, and the answer is 5. Now that means this is equal to 5. The j function at 2 is equal to 5. The j function at 2 is equal to 5. And then we're going to increase it by 3. So our answer is 8. Let's do this for the next one, k of 5. So to find k of 5, we're going to follow this rule of find the j value at 5 and increase it by 3. So let's go over here, the j value at 5, but we're going to increase it by 3. Take that answer of 2, increase it by 3, and we get a final answer of 5. All right, so we get a final answer of 5. So, and here's the thing. Since this is homework, I actually want to continue that pattern out. That means that for each of these values that we get for j of x, we're going to just increase them by 3. So to find the k of 0 is equal to this one at 0, but add 3 to it. 4 plus 3 is 7. And the next one, to find k of 1, we're going to go to the j function, find its value at 1, and then increase it by 3. 3 plus 3 is 6. I'm just going to keep saying this over and over so that we're hearing how we talk about functions. So to find the k value at 3, the value of the k function at 4 and at 5, eventually, this is just patterns and 6. This is all just patterns, and it becomes easy to see, oh, this is all we're doing. So to find this one, we go start here, take this value and add 3 more to it to get 8. Take this at 3, go to 3 in the j function, which is 7, and add 3 to it to get 10. Take the k function at 4, go to the j function at 4, its output is 6, but add 3 to it to get 6. Oh, 9. Oh, interesting. Oh, the values went up and now they're decreasing. Okay, I wasn't expecting that because I didn't really look at the numbers. And 5, take this, add 3 to it to get 5. Take this 1, add 3 to it to get 4. Okay, that's going above and beyond everything else here, but we can kind of pause the screen on that if you want to look at what's happening here. Okay, so the m function takes the j function, except it doubles the input and then puts it into the j function. So let's look at that. M of 3, to find m of 3, 3 is where the x is. So that means I'm going to take j, and where the x is, I'm going to put a 3. J of 2 times 3. All right, so, well, what's 2 times 3? 2 times 3 is 6. So really, this is the same as going to j of 6 and taking that answer. J of 6 is 1, and take that answer. So really what we did was we went to the j function at 3, we doubled that and went up here to 6 and took that answer. So m of 0. Now that's interesting. M of 0 is going to be going to the j function and doubling the 0 first. Well, here's the thing. If we go to 0 and we double it, we still get 0. So the output would still be equal to j of 0, which is that 4. That one's a special one. Okay, because it had that multiplying here. Okay, let's move on. I honestly, I asked you to do numbers 1 through 9 posted in Google Classroom, so that's what I'm hoping that you do. The graph represents the function f of x, so here is f of x, okay, and g of x is saying, okay, take the x value, go subtract 2 from it, find the value of the function at that new one, and then double it. So let's go to 1. Take the 1, go here to f of x, so we're going to go to f of 1 minus 2. And so here's the thing. We're not going to an x value of 1. We're going to 1 minus 2, which is f of a negative 1. We go there, take that answer, and then double it. We do that afterwards. So go to negative 1 on the graph. The answer is 5. So the answer is 5, but then we want to double that 5 to get a value of 10. That's how we interpret this. Let's do this last one, g of 3. The g function says if we're putting 3, we're putting that here where the x is. So to get g of 3, we're going to 2 times f of 3 minus 2. Okay, so we're not going to 3. We're going to 3 minus 2, which is 1. We're going to f of 1 first, and then we're going to take that answer and double it. So we go here. We go on the graph to f of 1, which is 1, which is a value of 1. Now the f goes away. It's that the output is 1, but then we're doubling that, and our answer is 2. Let's just do one more with this one. Let's say we wanted to go to g of 7. Well, to find g of 7, the function says, okay, that's an x value. We're going to go f of 7 minus 2. So we're going to go to 2 times f of 7 minus 2. 7 minus 2 is 5. So we're really going to the f function at 5, and then we're going to double it. We go to the f function at 5 is 1. Oh, man, same answer. And we're going to double that answer of 1 to get 2. So 2 times 1 is 2. So g of 7 is also equal to 2. G of 7 is also equal to 2. Same as g of 3. They both had the same output that then got doubled. All right, let's flippity-flip onto the back side. I'm going to zoom out just a little bit. And I did ask you to do these. All right, this is we are learning how to work with this. So we have the q function here. The r function says take the q function, but triple the x value first. Okay. Which of these expressions cannot be found? That's interesting because we only have these. So let's see. Let's take 0. Can we do 0? 0 times 3. I'm going to zoom in just a tiny bit more. What's 0 times 3? It is 0. Can we find q of 0? Yes, q of 0 is negative 4. We can find that one. 1 for an x value. Put 1 in here. Triple the 1 first. 3 times 1 is 3. We go here to 3, and the answer for the q function at 3 is 5. We get a value of 5. That we can do. 2. Okay. Take 2. Put that in as the x value. 3 times 2 is 6. So we want to find the value of the q function at 6. We go to the q function, and we're not going to 2. We're tripling it to 6, and we want to find the value is 58. That means this last one is the one that we can't do. And let's see why. 4. We want to triple that 4. And 3 times 4 would be, so R4 is equal to Q of 3 times 4. That's what we're doing. Put the 4 in that spot. 3 times 4 is 12. We want to find the value of the Q function at 12. And when I go here, this stops at 6. We would need to go all the way out to 12, and we don't have that information. Could make an argument that when we look at this, maybe we could find a pattern and work our way out there, but this is not readily available. All right, so that's why we can't really find that one right now. I am kind of curious to see, okay, so let's see. Going from here to here, this is like adding 2, and negative 2 to this is adding 3, and 1 to this is adding 4. Oh yeah, adding 5, no, adding 4, and then 5 to 14 does not add 5. We get 10. This adds 9. 14 to 27. Yeah, let's look at that. 14 to 27. Let's see, that'd be 28. This is adding 19. 27. Oh my God. This is not following a nice pattern. It's like, oh, it's not nice. Okay, that's why we can't find it. All right, 8. Here's another new function, also defined by q. All right, so z of x is equal to q of the opposite of x. Which of these can't be found? So let's go to -3. -3, if we put a negative in front of that value, would be negative 3. And what would that really be? That'd be +3. Can we find z of 3? Or q of 3? Yes, 5. We got that answer. That's the answer. We can do that. -2. Put another negative in front of that x value, -2. What does that mean? That means actually 2. So we want to go to q of 2. Can we find that value? Q of 2 is 1. Yes, we can. That one we can do. 0. 0. You toss a negative in front of it, and it's just going to be 0. And so it's going to be the q function at 0, which would be -4. We can do that one. And this 1, toss a negative in front of that 1, and we get q of -1. Now on the table, we don't have a -1. We can't get there. So that's another one why we can't do it. So this is the one that doesn't work. Both of these, the D ones, didn't work. Okay, here's another new function. T of x is equal to q of x minus 2. Now that means we're going to get the answer for q of x, all of these answers, and we're going to take away 2 from them. Take away 2 for them. It says if t of x is equal to 12, determine the value of x. So t of x equals 12. That means we're looking somewhere at the q of x function, and we're going to take away 2 from it, and we get a value of 12. So what number would we take away 2 from? We could add 2 to this and add 2 to this. We get 14 would be the value of the q of x function. And when does it have a value of 14? Well, right here it has a value of 14 when it's 4, when we're finding q of 4. So our final answer for this one is that the x value must be equal to 4 in order to get an answer of 12. So really it would be t of 4 equals 12. That would be our final answer, saying that's what, Okay, that is a lot of talking about this stuff. What are we on timestamp? Just a little over 12 minutes. There's a lot of new stuff here, so this is definitely worth practicing, going over. If you've watched it this far, good for you. You are doing what you need to do to kind of stay on top of things. Take care, folks. Bye.